Data Science Rabbit podcast with Michael Bagalman.
Welcome back to the Data Science Rabbit podcast, 2024 Presidential Election Edition. Have you noticed something weird about the battleground state polls? They're agreeing with each other like a suspiciously well-rehearsed alibi. On Friday, Nate Silver dropped a statistical bombshell that's making my data scientist's spidey sense tingle. These polls aren't just close. They're showing the kind of agreement that makes statisticians reach for anxiety meds. The reason scientists repeat experiments is that you don't always get the same results. If you survey 400 people each in multiple polls, you should see natural variation. So if the true split is 50-50, about two-thirds of polls should land between 47.5% and 52.5%. And one-third should be outside of that range. It's Statistics 101. What's Silver pointing out? These polls are clustering tighter than tech bros at a Silicon Valley networking event. And it looks suspicious. Polling isn't just ask questions, report numbers. Pollsters make judgment calls about everything from who counts as a likely voter to how to weight different demographic groups. It's like cooking. Everyone's got their own recipe, and it looks like polling agencies are playing it safer than a nun at a heavy metal concert. Silver suggests they're herding, tweaking their secret sauce until their numbers match what everyone else is reporting. Because being wrong with everyone else? That's just Tuesday. Being wrong alone? That's lost business in the next election cycle, assuming we have future elections. What does this mean? The battleground states might not be as close as this suspicious consensus suggests. But like a magic 8-ball dropped in a blender, we have no idea which way this thing's actually leaning. Though Tuesday night's results might not be as close as polls suggest.
Political polls in battleground states are 100% useless. Let me drop some mathematical truth bombs that'll make your statistician friends cry. The media treats state polls like they're fortune cookies from God, but they're more like fortune cookies from a drunk psychic with astigmatism. Here's why. In battleground states, we're not looking for the total support for each candidate. Shocking, I know. We're hunting for the difference between the two frontrunners. And therein lies our mathematical middle finger to polling accuracy. There's a relatively simple formula for the margin of error. Don't worry, I won't make you do calculus. The margin of error is 1.96 times the square root of P1 plus P2 minus the square of P1 minus P2 all divided by n minus 1. Yeah, definitely easier to follow when written down than spoken. P1 and P2 are the support for each candidate, and n is people polled. Now, in battleground states, P1 plus P2 will be very close to 1, because third parties are as relevant as your MySpace profile, and P1 minus P2 is close to 0. That's why they're called battleground states. Also, n minus 1 can be approximated by just n, and 1.96 is basically 2. Our margin of error equation simplifies to roughly 2 times the square root of 1 over n. Even with multiple combined polls, it takes a cold day in hell to get anywhere close to n equals 10,000 in any meaningful time frame. So the very best case scenario? A margin of error of plus or minus 2 percentage points, in a race tighter than spandex on a superhero. Translation: polls can tell you a battleground state is a battleground state, but they'll never even give you a hint as to who's going to win. Next time someone tries to convince you about poll predictions in a battleground state, just smile and nod. They probably also believe in risk-free investments and fat-free bacon.
In an age of information, ignorance is a choice. Donnie Miller's sobering reflection invites us to examine our role in the digital ecosystem, where each share, each repost, each casual mention shapes the collective understanding of truth. As data scientists, we're trained to approach information with analytical rigor, to question our sources, validate our assumptions, and seek statistical significance. Yet in our personal lives, how often do we apply these same principles to the compelling headlines and striking claims that populate our social feeds? The spread of misinformation isn't only the work of malicious actors lurking in digital shadows. It's sustained by the well-intentioned yet hasty clicks of those who mistake viral appeal for veracity. Like a statistical model with unchecked assumptions, each unverified share compounds the error, amplifying noise rather than signal. Consider applying these data science principles to your daily digital consumption. Sample size matters. One source isn't enough. Seek multiple reputable confirmations. Check for bias. Evaluate the source's credibility and potential agenda. Cross-validation. Verify claims across different reliable sources. Timestamp analysis. Check when the information was published and if it's still relevant. Correlation causation. Be wary of oversimplified cause-effect relationships. In our profession, we wouldn't deploy a model without rigorous validation. Perhaps we owe the same diligence to the information we choose to amplify in our digital lives. After all, isn't the pursuit of truth at the heart of both data science and responsible digital citizenship? As we begin another week, let's challenge ourselves to be more mindful curators of information.
This has been the Data Science Rabbit Podcast, hosted by Michael Bagalman. Find the Data Science Rabbit Podcast on all your favorite social media, including YouTube and TikTok. Follow Michael on LinkedIn or visit datasciencerabbithole.com.